So the recording has started, but it's not going to it's going to record only the screen. That's fine. So I can turn it off when we are having a discussion again. Okay, hello everyone. Good morning. Um, Following the lectures we had previously on system dynamics modeling, um, I'm going to introduce you how you can work in Stella. Actually, it's transformation from that how you can transform your conceptual model into a building model in Stella, and that can be actually parameterized for your simulation purpose. Before that, there is another thing, the conceptual model that you guys will have developed, we can actually draw in Stella. So the first task, what I'm going to show you, how you can draw that conceptual system model in Stella. So in the meantime, if you have any question, you can ask me. You can interrupt and raise your hand to if you have any questions. That's not a problem. So I can share my screen. Yes. Okay. You can see my screen, right? Okay. So the steps of system dynamics modeling, what I was telling, that actually we are now in this part because we have, let's assume we have the conceptual model, and then how you can actually draw that conceptual model in Stella. And then we are going to introduce this second part, step 5 to 8, because then how you're going to actually do the quantitative modeling part by building um, uh, the model in Stella, and the parameterization, how to do the parameterization, and how you can do the simulation and other analysis. So I just have opened a blank Stella Professional, which you need to purchase, but you can also use other software like Vincine. So it's my own license, so I'm not just promoting any of the software, but I'm trying to give you an idea of what software you can use. So let's assume I'm going to show you very simple model, because the idea is not to develop a complicated model, but just to show the different tools that you can develop your model at your own, for your own work. So what I do, for example, I want to have the population variable. I usually simply use the module when I'm developing the conceptual model on the top left, and I click it, yeah, and then you can rename it population. But you can actually keep the variables, or or you can also change to name only variables, like it shows only the names. Yeah. So you have to click actually on the bottom of the right side, this icon. This gives you that editing mode. So you can change the background color. So if you don't want the blue one, you can also change the font color. What color do you want? You can change the font size, the font and the font size here. But I'm going to show you how to change the font size altogether, but maybe I can increase the font size now that you can see everyone. Okay, then I'm going to add another variable which is known as now let's say agricultural land. Yeah, I have to do the same. That's a name only. Okay. And that's a increase of the font size. And then I'm going to add another variable in the simple model. I usually sometimes copy and paste just to avoid, you see, because when you are doing inserting a new variable each time, and then you're gonna have to click the name only and the change of the font and font size. So I just easily copy and I click it. Oh, if you double click, it's gone, but you have to turn it back on using this symbol. And that is arable land. Okay, and then is another variable I would like to add. I'm just adding that 5 or 6 variable at one time, and then I'm going to connect each other, and then it's a rice production. The final one I'm going to take this, the final one is life expectancy. Yeah, so let's connect. If population increases, yeah, the agricultural land decreases. When the agricultural land decreases, also the arable land decreases. So you can connect actually one by one using this connector, and then arable land has a relationships between rice production. Usually when you have if it's agricultural based economy, and if it's rice production is increasing, the GDP is increasing, and then it's contributing to the life expectancy by improving health and other facilities at different skills of the country. So when life expectancy increases, then also population increases. So you can see that is becoming a one feedback loop. You can ask questions why I'm not using other variable, because when there is during our lecture I was introducing that to build a system dynamics model you need this converter, this stock, and that flow. Actually, if you want to develop using this one, the complexity is that you need to have a different building blocks. Like for example, you need to have at least one stock in your model to draw a feedback loop. So to make it simple, when I'm developing the conceptual model, I usually use this module options to draw the conceptual system dynamic model or the causal loop diagram model in Stella. You can also identify or define the positive or negative relationships. For example, if you click in this small circle and then Stella has changed the option. So if you click this small circle, then it gives you positive, negative, and where you want inside or the outside of the arrow. Sorry. So I'm saying if population increasing, the agricultural land is decreasing. So you see there is a negative sign, but you can't see, so you can actually increase the font size. I want to increase more. Yeah. Then from agricultural land, you can do again to negative, but you have to also increase the font size. So this is how you actually draw the conceptual model, or the causal loop diagram model in his Stella. Ziren and Thu, do you have any questions?
No, I'm okay. Thank you.
Okay, thanks. So what I was telling is you can actually increase the font size at one time. So you just copy whole thing and then you increase the font size. So you don't need to change then each of the variables. In Stella, one of the easy friendly things is that you can simply copy and paste your model in your manuscript. For example, just copy and paste it. Yeah. So you don't need to actually you can try to save the image. Yeah, you can try to save that image, but it's not necessary always. However, you can try to save as a print setup. You can save the model. Let's say agriculture and population model. You can also, if you want, you can also print your model using the file, then using the print command in the left hand corner of the file. Okay, so let's transform this simple model to the building blocks using stocks, flow, inflow, and converter. So how you can actually develop your model and parameter, because I think that will be very interesting for a lot of other peoples. So now we can take this model at one side, because what is the purpose of the building blocks? Because now you have the populations, you need to parameterize, you need to tell your model the relationships between population and agricultural land. And I think the population is one of the most classic example in system dynamics model, because when people try to introduce system dynamics model, they try to give an example, and that's first come is a population, because I think that's very easy to make people understand how to develop the model. So do that. I'm actually starting here to that we can see the conceptual model and how it's developing that building blocks. What I'm going to do, I'm going to take a stock, because I'm going to conceptualize population as a stock, because population will be increasing over the time period. Yeah. Okay. I need to name it. See, that's another problem. I need to delete this one. I have copied in Word file, because I can't have two similar variable name. Population. In the same way, you can actually increase the font size, change the font, bold, italic format, and if you want to change the color. Okay, so for the population we need to have the one variable, that is birth. Yeah, and the birth is the inflow to the population, because it's increasing the population. To do the inflow, you need to click here and then you need to drag to attach to the main variable. Because this birth is actually increasing the populations, that's why you need to attach. If you don't attach, it will not actually be accounting inflow to the population, the stock variable. And then you need a birth rate. So depending on the birth rate, the population going to increase. I'm going to use a converter. Sorry. Increase the font size. Okay, so I'm going to tell, okay, the birth rate, connecting to the birth rate, and the birth rate is going to tell the portion of the population is going to increase. That's why you need another connector from population to the birth, because if the population is increasing and the birth rate remains same, it's accumulating over the time, because the population, if your population is higher and the birth rate is higher, it will actually multiply the birth rate, because there will be adding more people to the total population. And then when there is a populations, it's obvious there will be death rate or death. That means there will be outflow, because there is inflow and outflow. To join any outflow, you need to again do the attach to the main stock variable and stretch it and write it down as a death rate, as a depth actually. Okay. Yeah. So I did connect like a similar to the depth and death rate. Another thing is that similar to the birth rate, I'm going to have also a death rate. Okay. Maybe we can start parameterizing the variable one by one, because we're going to extend the model in this part, so it's better to have parameterization one by one, because then we don't have to do everything at one time. So I'm going to insert the birth rate. So I'm going to for the specific area we are working now, we have already collected data, and that data I'm going to use. So actually birth rate is not here, the birth rate is this fine. Okay, the birth rate is do the birth rate, you need to click this one on the model view, because this is the map view, which is when you are using when you're developing that your causal loop diagram, then you can use the map view. But when you want to parameterize the model, you have to click on this model view. In the model view section, you can actually put here an equation if you have like any mathematical equation, or if you have any numerical function. Like for example, here you know the value of birth rate, you can just insert 0.1. It's a 15% birth rate. So what you have seen is when you click the model view, it's giving a kind of yellow mark saying your model is not parameterized yet. So when I just parameterize the birth rate, the yellow mark is gone for the birth rate variable. But here, if I delete, you see again it's coming back the yellow mark saying your model is not parameterized. So when any of your variable in your model having this yellow mark, you can't actually run for simulation, so until you fix that problem. So that's a good thing that Stella is doing some cross-checking for you, that if you don't forget parameterizing any of the variable. Okay, so that's a simple one. The birth rate, you see, because there is a two input, one is population and one is birth rate, that is giving you a birth. So birth equals to population multiplied by birth rate. In stock, what are we going to do? Because here saying enter initial value, because you need to enter an initial value that depends on possibly the time frame. For example, if you are projecting or simulating from 1990 to 2010, and then 1990 is your initial value, or maybe depending on if you're let's say modeling rabbit population or the bird population, you can assume the initial value is 0. So depending on what you are modeling, your initial value is going to be set. So this is quite depends on your objective. So the initial value of the population is, I can copy here because that's a population. I'm setting as a 80 million, because now you can set up the unit, because you need to set up the unit. And you can click this green tick to make sure it's taking your input. Okay, that's gone. Similar to the birth, death is population multiplied by death rate. I'm not going to define the death rate now. Why? Because I'm not going to define the death rate similar to the birth rate, but slightly in a different way, which I'm going to define at the end of building of the model. So then you're going to see why I'm not going to define only the death rate. Okay, so what we have is population and agricultural land. But the population and agricultural land is not directly linked. There could be some other variables, but that depends on what you actually put in your model. that you boundary settings, like for example, if you're really concerned about the the built-up area, we're going to include a built-up area, and I'm simply going to do that by using the converter, an external variable. So built-up area, again have to click the model view to increase map view, sorry, to increase the font size, and then I have to link from population to built-up area. Okay, and then I'm going to have the agricultural land, because you see the main variable is the agricultural land. Okay, but then how I'm going to calculate the agricultural land, because you may don't have the agricultural land information, but you may have, definitely you should have from the national statistics or any other sources. But usually I'm going to introduce forest land, because when you have different variables, then you can actually try to test different hypotheses or different policy. For example, if the country is going to have no forest land, or if the country going to increase in the forest land, then what's going to impact on the total system. So the forest land and the forest and forest land and agricultural land going to be calculated from the total land area of the country. So definitely it's interlinked, and when built-up area is rising, also the agricultural land is usually decreasing. So you can actually, if you click it, this small circle, you can actually place or play wherever you want, just to design to look it, looks visually good. So depending on your perception, how you want to actually place it. I want to increase the font size. To do that, it's already in model view, but sometimes when you are working in sorry, it's already in map view. So when you are working on model view, again you need to click this model view to come to change the font size. See, okay, let's define the all these variables. Okay, what I'm going to do is, when we are having our lecture on parameterization, what is that? So when we are having this the lecture on parameter estimation, I was giving you can use actually equation, you can use the numerical value, like for example the birth rate that we have inserted, or we can also use the graphical functions where you can state, like a state variable, the time, or the different two other variables in x and y axis. But you can also try to define using this graphical function, like for example, if you don't have the data, lack of data, then you can try to assume the relationships, possibly using the stakeholder views, perception, or the historical changes of that specific variables over the time period. But in this case, we have the data, luckily. So in the model view, see, this is called the graphical function. I'm going to click the graphical function, and you need to switch it on, otherwise you can't insert your data. So as you already have actually define the relationships, for example, population and built up area is also taking the two variables, but you need to define your the x and y axis minimum and maximum value. If you go to the data, that's a population and that's a built up area. So you can take the minimum value and the maximum value. The maximum value is 160 million, and minimum value usually in the it's 90. In the data I'm taking as 80 million, and in the built up area I'm going to take this one. Usually it's better is little bit higher and little bit lower value from your data set. So you see it's little bit higher than the actual value in 2011, and then the minimum value is audible less than the original value started somewhere in 2000, because this is about 11 years data. Sorry, I can't remember actually which country's data sets I'm working on, but that's not an issue. It's the important is how you can parameterize the model. So once you have inserted your minimum and maximum value, what you could do simply three things to define your relationships. For example, let's say I'm going to tell, okay, when population increases, the built up area is also increases. Simply linear model. It's just going to tell you you can change a different relationships. For example, you can also include some kind of non-linearity, or maybe in a different shape, whatever you want. Sorry, but in this case it is a very linear function, and you can simply define as a linear function. You see, it's not very precise. So what I'm going to do, I'm going to click the point function, and the point functions is going to give you the two variables, so you can insert your datasets on your right and left side. For example, you can copy, built up area, okay. You need to actually, because as already I have inserted the value, you need to change one by one. You need to change one by one the value. So you need to tell another functions. What I do is that, to be more precise, actually I plot the population on the x-axis and the built up area on the y-axis, and I try to see how the relationships is changing. And if you see the starting point somewhere is 90,000, it's linearly is increasing over the time period. So I can really draw a map, draw a line. And that's give you more or accurate, but you can actually try to change, put your cursor and try to change your the value of the each variables. Often this variable in the y-axis, or it's an x-axis, yes, is easily, you can't edit, but if you want to edit, you need to click on this lock button to unlock it. So what you could do, either you can draw the line, or you can actually insert here simply, then it will be developing a draw line for your graph. Another thing is that you see the continuous, extrapolated, and discrete, what functions you're going to use. For example, if you're going to use your model for understanding the behavior of the system, for example, if you have a 50 years of data, let's say you have a 50 years of data point, and you want to test different theories, like for example, maybe any social-ecological system like a tipping point. So you're going to understand, okay, if there is a changes in policy, how the system going to behave. That means you're going to use the same time range, so you can use actually continuous functions to test the behavior of the system. But in case you want to project for the future, like say if you have a 20 years of data point, but you're going to project another 30-50 years, then you need to click extrapolated, because then you're going to take these relationships, learning from these relationships, and it's going to project for the next 30 and 50 years. But how we're going to do that, I can tell you, show you once we have developed the model. Guys, any questions at this point? No?
No.
Okay,
Thank you. I'm good.
Good. And you were in the same speed as I am, or you want me to slow it down a little bit faster?
It's fine. Yeah, it's fine. I can catch all your speed.
Okay, that's fine. Thank you. Just let me know if you have any questions, or I need to be a little bit slower. Okay.
Okay, thank you.
In the forest land, I guess now you are getting the idea of the value and everything. So you can simply use the forest data from here, and you can start here inserting your values. Again, what I did, instead of having a number or as a numerical value here, I used the graphical functions to show the model how it has been changing over the time period. For example, in this case, actually forest land is decreasing over the time period. See, I can show you a graph. See, so I'm inserting the historical value to tell, see, the forest land is decreasing over the time period. And how we're going to do that? Let's assume that's actually not a 20 years, that's 11 years of time period. And we need to again define the maximum and the minimum value. So the maximum value according to the datasets, I'm copying and just pasting to the maximum and minimal. Importantly, you first have to insert the maximum value. Don't insert the minimum value first, because then it's not going to take your value it will be deleted automatically. So you need to insert the maximum value first and then the minimum value. Okay, so you also need to change the data points because you have 11 years of data sets. I don't know, the new function is not copying and pasting the data. So what you need to do is actually insert one by one. Oops, why is the Excel's shit gone? So that's a forest value. Yeah. See, the graph is automatically changing. So you can do that in this way, but what I'm going to do is simply using the graph. I mean, just looking at the Excel file, how it's been changing. I can draw a simple line. Yeah, so this means the forest land is decreasing over the time period. And don't forget to click the extrapolator because we are going to simulate it for the more than 11 years. The total land area of the area, we are going to insert the total value of the total area of the country. And then the agricultural land area, I'm going to tell the agricultural land, let's assume we have only these 4 types of the land in a country. And then agricultural land is the total land area minus the forest land that plus the built up area. This is giving you the agricultural land. Yeah. So you see there's only yellow markings are death rate, and the rest of the thing is gone. So that means we have done more or less right thing. And then we have the arable land. Yeah, in arable land I'm going to again stock. So arable land is coming from the agricultural land, but the arable land, to calculate the arable land, is actually there is also other types of land we are going to consider, and those are, for example, the land with the cultivable with vegetables, the land with artificial pasture, the pasture land, and maybe any other types. Yeah. Oh, sorry. So because for example, in many countries, in response to possibly extreme weather, they're trying different type of vegetables. So maybe if you want to see that if we're going to increase the vegetable increase in that specific area, that what going to change, how you're going to change the system, so you can actually have this variable. So all this actually can give you the estimation of your arable land. I'm going to increase the font size at one time. Oops, this is very okay. See, Stella is again warning me that I don't have the value for this one. Okay, so what would be the agricultural land? The agricultural land, sorry, what would be the arable land? So the arable land is the agricultural land and the minus all the value of these land types. Vegetables plus artificial pasture plus pasture and plus others. Yeah. Okay, gone. And the vegetables, we have the data for the vegetables. Sorry, what I'm forgetting to do, which is very important, is that you need to set the unit, and that is here is a square kilometer. So it's already the units are loaded, so you can actually select or you can actually copy and paste, and then it can show you from their list. So it's all will be square kilometer. Yeah, so artificial pasture, going to take the value from here for pasture. And for the others. Okay, so we are nearly there. This part looks good, it's all done. And then the last two, the rice production. What I'm going to do is the rice production, I need area, rice production area, and also rice and rice yield. I'm going to see rice or model rice as a stock, so it's changing over the time period, and that's is rice. Yeah. Okay. Then I need definitely inflow and outflow, right? Because that's what I was telling you, that when you have a stock, you also need inflow and possibly also outflow. that is rice production, and that is rice consumption. Okay, for the rice production, because we have the arable land, we need to link with this arable land and the rice production, because we need to see which part of the arable land is using for the rice production. So we need a rice production area, production area. I need to increase the font size. Yeah, rice production area, and I'm going to use yields, rice yields. It was better to have altogether. So arable land connect to the rice production area, and rice production area and rice yields is actually telling you how much rice going to produce. Rice production area multiplied by rice yield. That was a simple one because we didn't need to insert any data. So rice yield. For the rice yield, we're going to actually use the time series data again, because we want to show that how the rice yield was changing over the time period, and we have it from our datasets. So what am I going to do? We're going to use graphical function again, and that's a time because we don't have any other variables that is driving the rice yield. So it is a time, and the time period is 11, data points 11, and the maximum and minimum. What I told you is that we need to have maximum value first, and then the minimum value, and we also need to set up the unit which you need to do when you are going to the map view, and there on the bottom of the right hand side, tons per square kilometer. Yeah, extrapolated. Okay, so is that when I'm going to draw the line? Okay, this is how it has been changing over the time period. It's not precise, but let's do it like this. You can draw a more precise way, or you can just insert the value, the exact value from your Excel sheet in the rice yield column. So you have already rice yields in the rice production area. in the rice production area, because the arable land and rice production area, because often the government has like a policy how much area they would like to see under the cultivation of rice, or maybe you can also see from the overall historical trends. Like for example, in case of Bangladesh, there is the rice production area or the cultivation area is not changing over the time period, but rice yield has increased over the time period. So maybe we can say the 75% of the arable land is under the rice production. So arable land multiplied by 0.75. So this is also another thing you can actually try to play or try to change um, this the rice production area and see how the whole system will be changing or responding. So the rice is in tons. The initial value, definitely I have copied from the Excel data. I don't know why my laptop is getting slower. Okay, don't forget to save your model. Yeah, I think it's similar to other software. The save button is in the file the right or the left side of your top, and then you can just click it as a save. Okay, I'm taking this value from the Excel sheet, and the unit is tons. And the rice consumption, yeah, to have rice consumption I need to have another variable, is a rice consumption per capita. Yeah, is rice consumption per year. Okay, so the rice consumption per year and the production over the year is actually can give you the idea about the total consumption, because we have the rice consumption per year, but we need to have the total population as well, because to estimate the total population, the consumption of rice by the total population. So what you can do, we have added a link from the population, and then the rice, the total, that's the total rice, and that's a minus the population, multiplied by rice consumption per year. So this is the total amount of consumption per in for the total populations minus the total rice. So it's giving you the leftover rice over the time period. Okay, the final three variables, because you see we had life expectancy. Yeah, the life expectancy is definitely not directly linked with the rice or the rice production, but could be with the GDP shared by rice. GDP shared by rice. And then that GDP helps possibly improving the health facilities, the sanitations, the medical, the other issues that related with the life expectancy, good food for everyone, and maybe increases the life expectancy. I think this is one of the classic model developed in system dynamic model. Okay, the relationships just I explained, I'm just defining now using the connector. I see when life expectancy is higher, your death rate is also decreases. Yeah, looks good. Okay, let's start then defining the relationships from life expectancy. Yeah, what I said, you can actually using the Excel you can develop this kind of bivariate plots to have life expectancy on the x-axis and the death rate one in y-axis, and to see how it's changing over the time period. And then you can start plotting come on, it's hiding over there. So I'm going to use graphical functions again. So death rate is the historical value, is the maximum is 0.12, the minimum is 0.06. Life expectancy is between 65. Oh, you see. So if I'm inserting the minimum value, it's automatically deleting. So the maximum value is 70 years and the minimum value is 60. So in average 5 years have increased. So when your life expectancy is higher, your death rate is lower. I'm just drawing based on assumptions the bivariate plot we have, but to be more precise, please use the point value, then you can actually insert precisely or exactly to the historical value. I'm clicking again extrapolate it. Again I have to do same for the life expectancy. Before that I want to increase the font size. Okay, so life expectancy I'm using the same approach. The life expectancy is 70, 65, 160, and that's a 70 GDP shared by rice. Okay, so and that is increasing over the time period. So the when GDP is shared by rice is higher, the life expectancy is also higher. Similarly, rice production is higher, GDP shared by agriculture is also higher. Okay, so GDP shared according to historical value, that's maximum, and then a minimum value, because I'm again going to tell you that this is from the time series data that we have in the Excel sheet. So based on your data sets, what is the minimum and the maximum value you have to set in the in your axis by the GDP shared by rice, and then also you have to do the same for rice production. And the bivariate plot I have is telling is simply linearly increasing over the time period. But if you want to have the precise information, please change the exact value, clicking the point function of graphical function. So don't forget to click the extrapolated if you're going to simulate for the feature beyond 11 years. Okay, all set. Yeah, don't forget to save. Now I'm going to run the model. Model, run a specification. Yeah, start time 0 and 12. I don't want to change it now because I'm going to see if the model can actually generate the historical behavior, because we have already used the historical data, and we can test if it is actually producing the similar behavior to the historical that we have observed over the historical time period. So you're going to spend time in it's a year, it's a yearly data. So I'm going to set the year. If it's your data is daily, monthly, you can set your time speed, simulation speed. Yeah, integration methods is the default like a Euler system, and leave the rest of the variable as it is. Go to model and click run. Oops. Rice consumption, see, one variable we have not defined. I have a troubling in my laptop. 0.173, that's a value I forgot to set up. Go again and run. See, it's running. But the then question, how I can see the simulation output. Click on the graph on the top of your left hand side. Click this one, and also if you want to see the data sets in table format, you can see the in the table one. But in the graph, you need to tell which variable you want to see as an output. Yeah, so which variable actually I would like to see? Maybe the population. Yeah, and also the population. Oh, oh. Click the population. So run. Here you go. So it's can actually telling you, oh, there's a two population variable. I just did one. Yeah, you can also change the other variables wanted to see. Let's, for example, um, what I'm going to see, maybe rice production. Yep. Okay, so maybe what I could do is now I change the run specification because I want to simulate for the 30 years, and if it's changing over the time, I mean how it's changing over the time period. See? Okay. Then the question come actually before I run the model. I missed one step, is actually when I'm setting 11 years of data, when I'm simulating the 11 years of data point, and then possibly trying to validate with the historical data if how it's changing over the time period. For example, the rice, because the rice we have not used here the graphical function, so I choose this variable as to validate my model and to see how it's changing over the time period. So you see the blue one is the actual the value, the historical value, and the orange color, that is actually simulating by model. That is more or less similar, but to be honest is because of the 10 or 11 years data and we have less variable, less complicated model. We are very close to the model, but that's not always the case when you are having a large complicated model. So one of the example that I can give you how to validate your model, that is actually in the previous lecture. For example, detailed model check, like we try to insert the correct unit, the variable relationships. You can go through each of the variables to see if the variables and the relationships are defined in a proper way or the appropriate way, or is it making sense. We can use also the stakeholder engagement to see that we have selected the right variables and the units and the structure of the whole system, which is known as a more structure validity. But then we have also the historical behavior, like the historical validity to check the simulation versus the historical value. And in a large complicated model, for example, in my previous work, you see it not exactly matching with the historical value, but it's within the range of the confidence interval, like 95%, which is definitely we can accept as a good fit of the model. So it depends on what is the purpose of your model. But often this is very typical approach, or maybe is also you could think of the approach if you have a historical data and you are using graphical function in your model. For example, if you have a 30 years of data point, or let's say 20 years of your data point, you can actually use this 20 years of the data sets to predict next 20 years of if your model can really predict for the next 20 years of data set, then you know that okay, you have more or less confidence on your model and it's ready for testing the different policies. So that is all from my part. If you have any questions, you can ask me in the comment box or you can send me an email. I hope you enjoyed the session, and it's just to show you actually you can use the different you can building the blocks, you can building the model using the 3 building blocks, the stocks, converter, and the flow, and then you can actually parameterize the model using the numerical values, using any equations. We don't have the mathematical equations here, but definitely we're trying to use a very simplistic one. But if you have any mathematical equations, you can insert a similar way into this box. So thank you very much. Thu and Ziren.